1, 2,
3.
react! The effects of the different coffee beans. Hi, my name is Amy Lafalo.
I'm Lilia Marquez.
And I'm Vanessa Gonzalez.
Now, how many of you like coffee? Or how many of you drink coffee?
Now, how many of you don't drink coffee here?
Okay. So those of you that do drink coffee, why do you drink it?
To those who don't drink coffee, why don't you drink it? Well, y'all gonna learn today why you should.
Okay, so the question of our experiment is, does coffee brands influence the response time? And what I mean by this is, does coffee affect you in a good way? Does it make you quicker or does it slow you down?
So, what is coffee? Coffee is a drink made of roasted, ground, bean-like seeds from tropical shrub. It can be served either hot or iced, and it contains antioxidants and caffeine.
Vanessa, what is caffeine?
Zainab, I'm glad you asked me that question. Because caffeine is a compound found in tea, coffee plants, and is a stimulant of the central nervous system.
And so our hypothesis that we conducted is, if you consume coffee, then your reaction time will be quicker than if you didn't consume coffee.
So our 3 types of coffee contain different levels of caffeine. Our Folgers coffee contain 95 milligrams of caffeine per cup, whereas our Dunkin' Donuts contain 101 milligrams of caffeine per cup, and shockingly, the Starbucks contain 180 milligrams of caffeine per cup, which is nearly double the amount of the Folgers coffee.
Alright, so our independent variable is the coffee, the participants taking the test, and our dependent variable is the reaction time, the number where the grass is located on the meter stick, and the control variable is the amount of coffee provided.
Okay, so the materials that we used is 1 meter stick, Starbucks French Roast Dark Coffee, Dunkin' Donuts Original Blend, and Folgers Breakfast Coffee. We also used 16 styrofoam cups, and last but not least, 16 participants.
Okay, so for our methods, we had 16 participants volunteer, and they fill out a survey so we can get their information if they like coffee, if they didn't like coffee. And we divided them into 2 groups. We had a drinking group, a coffee drinking group, and a water drinking group, which was our control. And the coffee group is divided into 3 subgroups that drank the Folgers, the Dunkin' Donuts, and the Starbucks. They drank their substance, their beverage, every day for 4 days, and their results were reported. We used physiology and physics in this experiment so we could understand what was happening in the bodies as the caffeine was consumed. So we didn't add any sugar or any creamers or anything, so the participants drank the coffee straight up black. And so that way you can get their reaction time accurate without anything else in between.
So the procedures we did for the reaction test is we grabbed a meter stick, and we had the participants cup his or her hands like this, like a crab claw. We then leveled the meter stick with the opening of the thumb so it's level at 0 centimeters. And we then dropped this in the meter stick. Well, as you can see, my reaction time is really slow.
Okay, so how we calculated it was getting the reaction time before actually handing the beverage to the participants. Then we waited 15 minutes, and then we recorded it, and then how we calculated it was by finding the mean average. Demonstration. We can show you the demonstration.
Okay, well, we'll just show you the physics demonstration. You have this equation that we used. That our y was for the amount that the participants went through, so meters changed to centimeters, centimeters to meters, and we use this into the quick plug, substituted our results into the equation, and got our time. So here you can see the control, and that's of everyone before they drank their substance, and that was of 0.189 seconds. Here we have our water after they drank it. That was 0.187 seconds. And our Dunkin' Donuts drank, okay, after drinking the Dunkin' Donuts, they had 0.178 seconds. Our Folgers was 0.156 seconds. They had 95 milligrams of caffeine. And the Starbucks contained, their reaction time was 0.164 seconds.
Lily, as in the other graph, before, can you tell me why exactly the Folgers had the fastest reaction time even though it had the least caffeine amount?
I'm glad you asked, Nessa.
No problem.
Okay, so the Folgers has less caffeine and it gave a quicker reaction time. This is because if there's less caffeine in the brain to block the receptors, the adrenaline levels will increase and it'll have a better chance at fighting the caffeine. So these are the average response times of everything before they drank and after they drank their coffee. So here, the water was 0.189 seconds, and the after was 0.174 seconds. That's a difference of 0.015 seconds. It may seem insignificant, but it really is because it does show that there is a difference between normal reaction time and caffeine reaction time.
Wait, Nessa, don't you know more information about that?
Zainab, I'm glad you asked again, because I actually do. Alright, so everybody has these nerve cells called neurons. And while these neurons rise up, they produce adenosine. Well, we have receptors in our bodies that alert us when our adenosine levels are high. So when this happens, it causes drowsiness, not brain, and then that means our brain and body need to take a rest. So actually, caffeine is actually structurally similar to adenosine, except unlike adenosine, it actually does not alert us when our levels are high, therefore our mind continues to function at a high level. So caffeine does not actually activate your brain and prevents it from hitting the brakes. That is when the adrenal gland comes in. The adrenal gland actually, when it sees the brain with no brakes, it produces adrenaline. Yes, adrenaline. So, when this happens, the receptors tell us when adrenaline is in us, so it is responsible for altering our reaction speed.
So in conclusion, our hypothesis was supported by our data, and we found, well, again, the caffeine isn't what really causes you to get hyper. It just inhibits the ability of your brain to stop doing what it's doing. So the adrenaline comes in, it kicks in and says, hey, okay, you're working hard, so you need to work harder. So it comes in, and the adrenaline is what actually comes and makes you hyper.
So for further applications, we actually made certificates for our participants. And we made them out of coffee grounds. They also smell like coffee, by the way. Here are references. We want to give a big thanks to Mr. Brandon Williams for helping us with the physiology part. Mr. Devon Lockard, Lockard. Miss Karen Rogers. Miss Kate McMorgan. And last but not least,
The participants. Comments?
Or concerns?
Jaden?
What did you do when you had one number when they were doing the reaction time that was pretty different from all the other ones that you had 6 centimeters, 8 centimeters, 4 centimeters, and then one was 22. Did you kill it or did you leave
No,
it?
see, yeah. Well, what we did is if there was an actual difference that made it happen that way, so if the person wasn't watching while we did it, they turned around and suddenly, and it did happen, we would disregard that because it wouldn't be their reaction time if they weren't focused on the meters.
How long did you wait after they drank the coffee? How long did you wait before
we waited 15 minutes. Well, at first, we did the reaction, and then we gave them the beverage, and then we waited 15 minutes, and then we tested them again to find the reaction.
Brenna?
Okay, so at the beginning you mentioned that tea had caffeine, right?
should affect your reaction. It doesn't necessarily have to be in coffee. So like if I saw someone drinking soda this morning, that has 45 milligrams of caffeine in it. And so, yeah, it still affects you.
And also, do you think that the temperature of the coffee could have affected anything?
Maybe the way they drank it, if it was cold, they drank it a lot faster. If it was hot, they spent quite time drinking it.
Did it affect the